we will teach you how to add two vectors together using a vector diagram. Before we start, there are some terminology that you need to be familiar with. Consider the vector here. The arrow tells you the direction of the vector. The length tells you the size or magnitude. Okay. This is the beginning of the vector, and this is the end of the vector. Now we may begin. Okay, there are three different arrangements of two vectors as shown here. Okay. Let's look at the first arrangement. Notice that this is the starting point of vector A, and this is the ending point of vector A. It happens that the ending point of vector A is also the starting point of vector B. Okay, so this arrangement is unique in this aspect. Okay, to find the resultant of the vector, of these two vectors adding together, we can use the analogy of walking. If we start from here, the starting point of vector A, and we walk along vector A, and after that along vector B, okay, is there a shortcut to reach this position, the ending position of vector B, from the starting position of vector A? Okay, the shortcut from the starting point of A to the ending point of B, okay, will be this line. Okay, and this will be the resultant vector of adding A and B together. Okay, and I'm going to indicate the direction of the arrow using two arrows. Okay, now we look at the second arrangement. For this arrangement, notice that the starting point of A and B are the same. Okay, for this case, we will need to shift the vector to get a similar arrangement as arrangement 1. There are two possible vectors that can be shifted. A can be shifted down such that the ending point of A is the same as the starting point of B. Okay, first measure the length of A. Okay, it happens to be 5 cm. Without shifting the ruler at all, we draw another 5 cm. We extend the line by another 5 cm. And we call this A prime. Okay, notice that the ending of vector A prime is actually the starting of vector B. Okay, now we are in the position. Now this combination is similar to arrangement 1. Okay, we are now in the position to draw out the resultant of the addition of vector A prime and B. Okay, it's similar to the arrangement 1, where we are looking for the shortcut from the starting of A prime to the ending of B. This is the shortcut, and this is also the resultant, and the direction we will use a double arrow to indicate. Okay, alternative, we can also shift vector B. Okay, first we have to measure vector B, and it happened to be 4 cm. So what we'll do is we'll extend vector B by another 4 cm as shown here. Okay, and the arrow must be the same direction as vector B. So we will call this shifted vector B prime. Okay. Notice that the ending point of B prime is also the starting point of A. So we are now in a position to do the same thing as in arrangement 1. To determine the shortcut from the starting of B prime to the ending of A, that will give us the resultant of adding B prime and A. So I'm going to draw the resultant now. And again, the direction, the shortcut is from the starting point of B prime to the ending point of A. So the direction of the resultant will be this way. Okay, as indicated by the double arrow. Okay, there are two possible ways of shifting the vectors. Vector A can be shifted down such that the ending of B is the starting of A. Okay, so first you measure the length of vector A. It happens to be 5 cm. So what you have to do is to extend vector A in this manner by another 5 cm. Okay, and we will call this new vector A prime. Notice that the direction of the vector A prime is same as the direction of vector A. Okay, now we have reached the position similar to arrangement 1, where the end of vector B is the starting of vector A prime. So we are in position to use the shortcut analogy to determine the resultant vector. So since the starting is here and the ending is here, so the shortcut is as good as this line, and the direction will be this direction, indicated by the double. Okay, alternatively, we can also shift vector B. Okay, first, again, we have to measure how long vector B is, and it happens to be 4 cm. So what we can do here is we will extend vector B by another 4 cm in this manner. Okay, and the arrow of this new vector should be the same direction as B, and we will call this new vector B prime. Okay, so again, the ending of vector A is now the starting of vector B prime. So we are in a similar position of arrangement 1, where we can actually use the shortcut analogy to determine the resultant. Okay, so the start point is here and the end point is here. So the shortcut will be this line, and the direction is indicated by the double arrow. Okay, in summary, through the three different arrangements, we have learned how to add vector when they are placed together. Okay, this is the first arrangement. Second arrangement, notice that whenever we shift vector, we always shift the vector along the same line. For example, A to A prime, B to B prime, all along the same straight line. Okay, arrangement 3, similarly, A to A prime, B to B prime. Okay, finally, I'm going to share with you the name of this method. It is called tip to tail method. Why is it called tip to tail method? Tip means starting. So you can see that the resultant is drawn from the tip of A to the tail of B, which is the ending of B.